Thank you everybody for joining us. My name is Sri Ranganathan. I work at Capital One Center for Machine Learning. For today's session, I am joined by my colleagues Mike McCarty, Joe Wolf, and Ryan Soley. In this session, we will talk about Rubicon, a tool we have recently open sourced. Before we venture into its features and workings in detail, I would like to give you a brief introduction of what Rubicon is and why exactly did we develop this tool. For those of you who have been involved with model development, you understand how time consuming and tedious the processes associated with it are. We know that model development utilizes many complex and iterative processes, and over time, they become extremely difficult to keep track of. At some point of time, every model developer has asked themselves some of these questions like, how should I track my model experimentation over time? And if I tracked all the data, how do I visualize it? How do I see the trends or gather additional insights from it? How do I collaborate with others? How will the reviewers access the data? How do I get my final model approved? So we honed in on these struggles and understood how much valuable time is being spent on simple tasks like tracking the data and how much it distracted from the actual development process. And that basically gave us the idea for Rubicon. So, what is Rubicon? Rubicon is a tool or a library that we have developed for data scientists. It's lightweight, it's Python based, and it helps data scientists and model developers track their experiments during the build and train phase of model development, visualize the results for further exploration, and extrapolate trends and insights. It provides standard, complete, and automated experiment tracking for model documentation so the training information such as hyperparameters and metrics are never lost. Model developers have the ability to integrate Rubicon directly into their model pipelines and can easily start tracking information such as features and hyperparameters for a particular model fit, metrics produced by a particular model fit, any data frames or artifacts relevant to the model fit. And by artifacts, I mean pickle model objects, images, complex metrics, etc. Apart from that, the users of Rubicon are in charge of where the data lives and can decide to log locally to their file system or to an S3 bucket. Rubicon is available under the package name Rubicon-ML and can be installed either using Conda or pip. It enforces best practices like integration with Git and helps associate the inputs and outputs gathered with the model code, thereby ensuring full auditability and reproducibility. It also provides users with the capability to create and associate data with tags to stay organized. Rubicon comes with an integrated dashboard to explore, search, filter, and visualize log data to easily identify patterns and tweak the model towards an optimal solution. It makes this organization and data exploration simple by supporting tag filtering and by automatically grouping experiments under the commits over time. Apart from this, Rubicon also offers concurrent logging and asynchronous communication with S3. So multiple experiments can be logged in parallel and network reads and writes are not blocked. With that, I will pass on the control to Joe, who will walk us through the main components and features of Rubicon in detail.
Okay, so now we'll jump over to the docs and we'll start with the glossary. So just to give you an idea of the terminology as we go through the rest of the documentation here, when we talk about a project, that's the top level object. It's a collection of experiments, data frames, and artifacts, and projects are identified by a unique name. And then a project basically holds a bunch of experiments, and you can think of your experiment as an individual model run. And then you log experiments to projects, and then you log parameters and features, which would be your inputs to experiments, and then metrics, which would be your outputs to experiments. And then additionally, we also have data frames, which can be logged to experiments or to the actual project. And then we also support artifacts, which would be the catch-all object for any type of object that you want to log to either the experiment or the project. And then we can look at how to install Rubicon. So right now Rubicon is packaged under the Rubicon-ML name, and it's installable through Conda by Conda Forge or through pip. And then additionally, there are a few extras that come with Rubicon. So for example, if you want to use the UI, you can install the UI extra. There's an additional integration for Prefect, which we'll cover later. And that has its own extra. And if you just want to install everything, you could do that as well. So now we can take a look at the quick look example. And this example covers the three main components of Rubicon. So as we mentioned before, that covers the Python logging library, the dashboard, and then the publishing and sharing process. Let's open this up in Jupyter Labs so we can work through it together. All right, so for this example, we're going to just create a simple classification model using scikit-learn to identify and classify different kinds of wines. So we'll just run this first cell here, which is just going to be loading the data set, and then we'll get into the Rubicon piece. So we'll start with the logging library, and as we mentioned, it's a Python library, it's lightweight, and there are different configurations for where to log the data. So you can log in memory, which would be, for testing purposes mainly, or you can log to local or S3 right now. And the important thing to note is that this is built on top of fsspec, and it's extensible. So any file system that fsspec supports, Rubicon could potentially also support. These are just the ones that we support currently. So for this example, we'll just log locally, and what we'll do here is set up our top level Rubicon object. So we'll set the persistence to the file system, which will be local by default, and we'll set our root directory to the current path at this Rubicon root folder. And then we will create a wine classification project. And that's what we got here. And then now we will run an experiment, and for the purpose of this example, we just consolidated a bunch of Rubicon statements into this run experiment method. But when you're integrating Rubicon into your model code, you can just do it however you see fit. So this run experiment method, we're just going to first log an experiment to the project, and then we will log some parameters, we'll log the features, and then we'll actually go ahead and make our pipeline, and we'll fit this, and then we will predict on it, and we'll log our metric accuracy. And then additionally, we'll have some details that we want to log as a confusion matrix, and we can just add that as a data frame on the experiment. And then last, we will add tags to the experiment. So if our accuracy is greater than 90%, we're going to just call it a success so that we can find it easily later. Otherwise, we'll mark it as a failure. So we'll run that. And then here, we're just going to run a bunch of experiments through this method. And yeah, there we go. So now if I looked under the Rubicon root folder here, we see our wine classification project, and we see our experiments, and here they are all logged. And then if I dove into each one, you would see the corresponding objects logged underneath it. And then, as I mentioned, we support S3 logging, so the only change that you need to make there is just to the root directory. If you wanted to use S3, you just prepend the S3 path, and it will automatically start logging to S3 as long as you have your credentials set up and configured properly. And then you could also use memory persistence, which would just be for temporary exploration. And now that we logged a bunch of data, you can imagine over time you've been running a bunch of experiments and you want to look back on this data to see if you can identify trends or really just see which experimentation led to the best model results. And so to do this with Rubicon, you would use our dashboard. So I'm going to run this so that it's spinning up. And yeah, so I ran this in Jupyter Lab, so I set the mode to Jupyter Lab, but this could be run directly, like from Jupyter Notebook. You could run it from our CLI, or you can run it as I just did here in Jupyter Lab. And so within this dashboard, you'll just see the list of your current projects on the left. I just have one, which is the wine classification that we just ran. And if I click that, it will load the experiments, and we could see our model name here, and that we have 14 experiments logged. And if I drop down here, we see our experiment table, and just right off the bat, you could see we can filter our data so that we just look at our experiments that were successful, and we could start comparing the parameters and metrics here. Additionally, if you had MAR data, it's pretty difficult to figure out what parameters are having the most impact on your metrics. So we have this plot that kind of provides a little more insight there through this nice visualization. And so you can imagine, if you have a bunch of parameters, you can start playing around and seeing which ones are leading to your top metric results. And this is configurable, so you can play around with this and move things around. And if you have multiple metrics, you could also select different metrics, and the plot would update accordingly. So that's the dashboard. And we can go back and look at the final piece, which would be the publishing and sharing process. So this is mainly for collaboration, and as we mentioned above, you could log your experiments to S3, and then anyone with access to that S3 bucket would be able to pull down your experiment data and view just as you're able to. So that's one way to collaborate, but taking it further, we wanted to offer a process that would let you select a subset of your experiments. So, experiments that you wanted to highlight after all of your experimentation was complete and you're happy with your model result. An important thing to call out is publishing does not change or move the data, it simply references it. So in this case, we'll publish all of our experiments that have the success tag. And if we look at a sample of this output file, you could see the experiment with its ID, the project that it's under, and then where the actual experiment data sits. And then this YAML file could be passed around to whoever you want to view the data, and all they need to do is import intake and open the catalog file, and then they could start exploring your data. And that wraps up the quick look.
Rubicon was designed to be easily plugged into your existing workflows and play nicely with the popular tools and technologies you're already familiar with. Sometimes, when we particularly like how a user has integrated Rubicon with an existing tool, we'll pull those additions right into the library itself. In this next section, we'll take a look at a few of these cases. First, we're going to check out how Rubicon works with Git and Github to provide model code traceability. Then we'll take a look at Rubicon scikit-learn integration to show just how quickly you can add Rubicon logging to your existing code. And finally, we'll check out the prefect tasks the Rubicon library provides to add logging into your workflows. Let's hop over to GitHub to take a look at our first example. Here, we have a simple repo where we're developing a simple classification model. If we take a look through the commit history, we'll see that we've already tried a few different things. Let's take a look at the code for one of them. So in mymodel.py, we're using a scikit-learn pipeline to run our data through a simple imputer to clean up null values, and then through our classifier. In this one, at this commit, we're trying out a random forest classifier. Then we're using a grid search to try out a few different sets of parameters. After we try everything, we will use this function to log all of our results to Rubicon. Now, enabling Rubicon's Git integration is simple. All we're doing is adding the auto-git enabled flag when instantiating the Rubicon object. Now, whenever we log a project or experiment from a directory that contains a Git repo, the repo URL, branch name, and commit hash will be automatically populated in our Rubicon data. Now, this is where Rubicon really shines. If you're familiar with this output from the grid search here, you'll know that it's a lot to look at. But since we logged everything to Rubicon after we tested it out, we can use the dashboard to easily inspect our many test runs. Now, you've already seen how this dashboard can be utilized to easily compare a large number of experiments. With Git integration enabled, we can organize our experiments even further. Each group here contains the same information you're used to seeing and can be compared in the same way to draw results from everything we have here. But at the same time, we've got some extra information added in. Now we'll notice that each group here also references a commit hash. These references not only show us what commit the experiment was logged from, but provides a link straight to that code in GitHub. So here we are back to our random forest classifier commit, and we can look at the mymodel.py code exactly as it was when we ran those experiments. The same is true of any of our other two groups here. So we can pull up this commit here and see our kneighbors classifier code, as well as this commit here to see our decision tree classifier code. Now, once we've got all these links, we can explore the code base at the exact state that these experiments were logged from. And if we say decide our random forest classifier is the best, we can hop right over here to commit 80 and continue working from here to see what we want to do next. Next for us today, we'll take a look at Rubicon's scikit-learn integration. In the Git example, we defined a custom function to log our grid search results to Rubicon. However, logging the results of a scikit-learn pipeline has become a common task among Rubicon users, so we made it even easier with the Rubicon pipeline. The Rubicon pipeline is an extension of the standard scikit-learn pipeline that automatically logs parameters and metrics based on the inputs and outputs of the estimators in the pipeline. Since it extends the scikit-learn pipeline directly, it also implements the scikit-learn estimator specification. That means it can be used with existing scikit-learn tooling like grid search. So speaking of grid search, here's an example of how to use it directly from the scikit-learn documentation. The example uses grid search to train a pipeline composed of 3 estimators across a set of parameters. So I'm just going to copy this code right here over into a notebook so I can illustrate just how easy it is to get Rubicon logging integrated. So first, we will just import Rubicon and the Rubicon pipeline. This all comes included with Rubicon. You'll just need to install scikit-learn. So once we've got that imported, we will simply instantiate our Rubicon object. And for this example, we're just going to log to our local file system. And we're going to create a project to store all of our experiments. Now, once we've got this project created, all we need to do is replace the scikit-learn pipeline with the Rubicon pipeline and pass that project along as the first parameter to it. And now we're ready to go. So we can simply run this notebook, this example, exactly as it was with our new Rubicon pipeline. And soon we will have 120 experiments, one for each of the 120 fits noted in that output there. Now, while we're waiting here, we'll get the dashboard set up so we can review these results. Now, instead of just looking at the best parameters and score like the original example, we can explore each experiment the grid search tried with the dashboard. So we'll just select our project here and load up the experiments. And now, at first glance, this table clearly has a lot going on. And that's because the Rubicon pipeline's logging is very verbose by default. It logs each input parameter to each estimator in the pipeline. Now, we can filter these columns down on the dashboard to create a more concentrated view, but we also provide user-defined loggers to the Rubicon pipeline in order to tell it exactly what we want to log. So built into the library, we currently have one user-defined logger for filtering, and that's what I'm going to import right here. And now it's also easy to make your own, but we won't cover that today. So if we hop back over here and give our project a new name, now we can also provide these user-defined loggers to our project. So in order to reduce the clutter on that dashboard, this time we'll only log the inputs that we're interested in. So we'll use this filter estimator logger to select only the parameters into the count vectorizer that we care about. Now, for the transformer here, we aren't varying any of these parameters, so we don't need to log any of them, so we'll just ignore them all. And for the classifier itself, we'll do the same thing as the count vectorizer and just select the ones that we're varying across our different experiments. Now that we've got our filters defined, we can log another set of experiments to our new project. This time, we should only see the 5 parameters specified by our filters logged to each experiment, and that'll give us a much cleaner dashboard experience. It'll be a lot easier to compare and contrast our experiments and see how our parameters are affecting our metrics. So once this finishes, we'll hop on over to the dashboard. And now we can select our second project and see that we've only logged the parameters that we care about. This time, it'll be much easier to explore how these parameters affected our outcomes. We can select all our experiments and get a much less cluttered overview of our experimentation. The main goal of Rubicon scikit-learn integration is to get users up and running with Rubicon as fast as possible, so we're always welcoming additions to make things even quicker and smoother. Now, last but not least, let's take a look at Rubicon's Prefect integration. If you're not familiar with Prefect, it's an open source workflow management system with a Python API and a great local UI that we'll take a look at in this example. If you want to learn more about Prefect, you can check out prefect.io. So, to get started here, first we need to start a local Prefect server. Prefect offers cloud and local hosting. For now, we're just going to use the local hosting, and we'll show a few more advanced configurations later on in this example. But once that's started up, we just need to also start a Prefect agent. And if we hop down here, we'll need to create a project for this example. So now that we've got that all set up, we're ready to get going. So creating Prefect tasks is easy enough on its own, but we've added some simple ones here to the Rubicon library. These are just wrappers around the existing Rubicon loggers, and they don't do anything extra that the logging library itself doesn't do other than work nicely with Prefect. We'll need a workflow to integrate Rubicon logging into, so let's put together a simple one. This should look pretty familiar to the pipelines we've put together in our last few examples. So we're going to define some tasks here, which are Prefect's unit of work for loading data, splitting data, extracting some feature names, and finally training a model and getting an accuracy score. So this piece here should look similar to some of the examples we've already seen today. Now, without Rubicon, our simple Prefect flow, which is the overall unit of work that Prefect does here, looks something like this. We just have our 4 simple tasks, and we can register the flow with Prefect to get this ID that links out to the UI. And we can use this block of code here to start it, and then hop back over to the UI to see our run in progress. So this is a simple flow. It's only going to do these 4 tasks, and it should finish them up pretty quickly. And if we hop back over here, now we logged that accuracy metric, or we didn't log it, we got one. Now we want to see what it is. Getting that information back out of Prefect can be a little cumbersome. So you can see here there's a lot of digging around we need to do into the results of the tasks just to pull back this one accuracy metric. So that's where Rubicon's going to come in. We can leverage the Prefect tasks within the Rubicon library to log all the info we want about our model run. Then we can use the standard Rubicon logging library to retrieve and inspect our metrics and other log data. So this will be much simpler than digging through the state of each of the executed tasks to extract results that way. So Here's the same flow from above, but this time we've integrated our Rubicon tasks that we imported at the beginning. So we're creating a project and experiment here, we're logging some features and parameters, and finally we're logging our accuracy metric. So again, we can start this flow and get a link over to the UI, where this time we'll see a little bit more going on since we're doing a few more things in our flow run. Now, once this loads up, we'll notice all of our feature logging tasks and parameter logging tasks and a bit more going on up here in our actual timeline of the flow. So we can then use the Rubicon logging library to quickly pull back a lot more information than we could with just extracting it from the Prefect tasks. There's one last part of our Prefect integration we like to show off today, and that is concurrent logging with Dask. So Prefect plays nicely with Dask in order to provide parallel computing when possible. The Prefect scheduler is smart enough to know which tasks do and don't depend on each other, so it can decide when to run tasks at the same time. So let's run the same flow as above, except this time we'll log 8 experiments instead of 1 with 8 different parameter sets and 8 different accuracy results. So first off, we'll start up a local Dask cluster and import the Prefect Dask executor. And before we get going, we'll need to slightly redefine one of our feature logging tasks. So this is so that we can log a whole set of features at once instead of just one like the Rubicon library's task does. And this is just to show that Rubicon's tasks are very simple. There's not much going on in them. This one is actually far more in depth than all of the ones that have been imported from the library itself. So we can come down to our flow and notice 2 main differences, and that is that we have a whole set of inputs now, and we are mapping a number of our tasks here, and that's just so that they run across all of these inputs. And we're also providing our flow with our Dask executor, and that's telling it to run it with that as a backend rather than the normal local scheduler. So we can define that and get our flow registered and started and hop over to the UI. And if we take a look into this flow, we will see even more going on in the last one, and we'll start to see some things happening at the same time in this timeline up here, as you can see right here. So this is going to execute 8 experiments this time, and it's going to know what it can do and can't do at the same time. So it should save us a little bit of time as opposed to just running it with the normal local scheduler. Then, once this is all finished up, again, we can go back to our notebook, and instead of trying to dig through all of that stuff with the Rubicon library, we'll just use the dashboard this time to check out everything we just logged. So here we have the 2 projects we just did. We can check out the mapped one that we just logged with our 8 experiments, select them all, and compare them to see how all of our inputs affected our accuracy metric. To recap, we've seen how Rubicon integrates with Git and Github in order to link experiment runs directly back to their source code, how the Rubicon Pipeline can get scikit-learn users up and running with Rubicon logging in no time, and how Rubicon plays nicely with Prefect to log in more complicated workflows. We're always looking for new ways to integrate Rubicon into existing tools in the Python and PyData ecosystem. If you're using Rubicon to enhance one of the tools you use every day, feel free to open an issue or PR on our GitHub repo. We'd love to hear about it.
Now that you've heard from Joe and Ryan on how to use Rubicon and how it integrates with some tools and libraries, we would like to hear from you as to what features we could add to make it more lucrative. Please feel free to open an issue on our Git repo for a feature request. The repo info is as shown in the slide. If you have discovered a bug and want to address it yourself, or if you're willing to make a contribution, open a PR and tag one of us to review it. We're very excited about this tool and see a great potential for it, and we want you all to be a part of our journey. Thank you once again for taking time today. Hope to hear from you all soon.